that doesn't take into account the 0.3 weighting to it, though.
Oh!
Taking the possible payoff of square root.
Yes, this was the key thing I wanted to get in this one. Excellent question. This is what I was focusing on, expanding our original chart. Now we're going to calculate the utilities. Okay, I'll do it and then see if that makes sense.
Yep.
Thank you. Okay, so, which is EU, just makes me want to go traveling. That is the weighted utility for each decision by probability. So you've calculated this kind of stuff before. You calculate it every time you try and find your GPA or your final course grade by the weightings of what each piece is worth. So let's do the expected utility of buying the stocks. So we have a 0.3 chance getting 40 utilities. And, because this is all one decision, we have a 0.7 chance of getting 0 utility. And that's going to equal 12, hopefully, unless I did something wrong and you'll let me know. Now, the expected utility for A2, well, what's our probability? No, you're going to get that no matter what. So the probability is 1 and times the utility is 15. Okay. Now, which one's Bill going to pick? Anyone? Bonds, why? Higher utility. Okay, so that is a simple, very simple decision tree and payoffs to calculate utility. Now, because buying stocks is much more quantitative than so many, although, you know, you can weigh your, like if you had a pension plan versus not a pension plan, you can weigh that kind of stuff in and turn it numerical. Having a good job, good boss, that's harder to do. Having tasks you enjoy, that's harder to do. But investments are fairly numeric, okay? So, do you see how you could technically apply probabilities? Okay, now obviously in real life, those stocks, is it just high or low they could be? No, they could be medium or medium, as many probabilities you wanted, okay? And if you look at true decisions being made, where they've studied them and they've done studies and studies of rational decision making, you can put a whole probability function in to better estimate how they made that decision. Okay? It's kind of neat. We don't need to know, we just kind of need to understand the basis, because our job as accountants is to make Bill have enough information. Not only can he get the payoffs right, but that the probabilities, he can predict them. Does that make sense? Okay. Anyone still need this? Okay, so moving back to the PowerPoints. Okay, so the investor can choose to wait and get more information before making a decision. Whoops, sorry. So Bill, sitting here going, well, you know what? There's the quarterly financial statements in a week. Maybe I'll wait and get more information. What can he do once he has more information? Will his probability stay the same? No, right? So that's the benefit of waiting. But what happens if he waits? He could miss out, right? Maybe the stock price is really low and then it's going to go up. So if he bought now, the stock would go up. But if he waited, then he's buying when it's high, because as soon as that information hits the market, the stock prices change. Or if So the investor has to weigh the benefit of a potentially higher utility with the opportunity cost of waiting and possibility of losing an information advantage. Now, example 3.1 continued goes into Bayes' theorem. Which looks at how to build in these new probabilities. So the prior probabilities, which were the original ones, haven't changed. But now there are posterior probabilities to contend with. Okay, so I'm going to go through the rest of, and again, it's in your text, you guys, and I'll put up this recording in case you missed something and need to re-look at it again. Okay, so basically what's going to happen? Bill has his stocks, right? High 30%, low 70%. He waits for an earnings announcement or something. And it's either good news or bad news. Well, if it's good news, okay, like it says, wow, look at our net income. Or our earnings per share went up. Is he more likely to have a higher probability to buy the stock? Now that he's heard good news about it? Yeah, right? On the other hand, if it's bad news, he's more likely to go, maybe I better not take it. Okay? That's what we're saying posterior probability is. The original, nothing had happened yet. He's using all the information from the past. This one, he waits a little bit, gets new information, and things are revised. Okay? Now, generally a lot of calculations, but I like to put one or two in. The two that are going to be is this one, and then there's one later on whether an employee should shirk or not do their job well. I keep those in because you guys, we're accountants. We like numbers. We figure it out. Oh, come to a right answer, right? So these are the two. Otherwise, it's all kind of written stuff, okay? Okay, so with this one, Bill is going to wait for an annual report. Okay? And it doesn't just have to be an annual report. Remember when, I think it was Volkswagen, they got caught cheating on their emissions tests, right? So there was rumblings leading up to that before that announcement was made. So you could sit there and go, you know what, I was going to buy it, you know what, I'm going to think about it and wait and see what they say. That's the kind of information, okay? Or an earnings announcement, or you heard there's going to be a change in CEO. All those things can affect stock price. He's waiting for an annual report. The annual report comes in. Or comes out, I guess I should say. And it shows good news. And we're going to call that GN. Now, one thing to consider, and this is thinking about the stock market. Just because you get good news from an annual report or from an announcement or from the new CEO, does that mean the company's going to perform well in the next quarter? Has any company ever said, oh yeah, we're doing great, and then they crash and burn? Yeah, right? Think Enron, think WorldCom, think many of the companies in 2007, 2008, right? Many banks in the US. So, remember, good news report doesn't mean it will perform well. It will perform well. So there's still risk of poor performance. So, he heard there's good news, so now there's revised probabilities. So, we're going to revise the probabilities. So, the probability of good news of high, given that good news has occurred. I'm going to write that out. Of high performance, given good news has occurred. That's how you'd read that. So the probability of high performance, given that good news has occurred, is 0.8. So now we're in 80% chance. And the probability of bad news and high occurring is 0.2. So notice that you always add to 1. So, these are what's called conditional probabilities. Something's occurred, so now the chance of something else is X or Y. Now, kind of matching that, thinking of good news and low, we can do the same kind of thing. So also, probability of low happening now that good news has been announced is 10%, and these are given, you guys. You don't make these up. And what's the opposite of this one then? 0.9, and it would be probability of low given bad news. And again, they add up to 1. Notice these are paired up and these are paired up. Okay, make a little note for yourself. Prior probability haven't changed. So probability of high is still 0.3, probability of low is still 0.7. So Bill's original probabilities have stayed the same. High 0.3, low 0.7. But now that he weighted and got the report, found it was good news, he's got some other probabilities to work with. Okay? The top ones in black are the probability of high occurring news, because that's the thing that's happened already. And here's the probability of low occurring, given we've heard good news. So, what we need to know is the probability good news has happened. What is the chance it's going to be high? Guys, I might have reversed this. Damn it. This is probability of good news performance. Probability of good news given high has occurred. Sorry about that. So these things in red have occurred. Sorry. So let me say that again about this. These are conditional probabilities that high has occurred, what's the chance news or bad news candidate? Low has occurred, what's the chance it would be tied to good news or bad news? Okay? We want to know what's the probability, given the good news, that high occurs. So the second occurred. I said it right the first time and then changed it. Does that make sense, you guys? Or have I messed up? Okay, well, let me go through Bayes' theorem, then I can recap it and we'll see. So Bayes, and remember they've come up with these theorems, they've studies, that kind of stuff. Bayes is an old theorem, so it's pretty steady. This is the formula. Probability of high, given that good news has occurred, is going to be the probability of high times the probability of good news given high over the probability of high times the probability of good news given high plus the probability of low times the probability of good news given low. So the second ones have occurred. And questions on an exam, you guys, I'll give you this formula, okay? Because that's not something you need to memorize. Okay, so let's put in our percentages. What's the probability of high just all by itself? .3. And the probability of good news given highs already happened. But the top, that was 0.8. So that's kind of flipping things around. It's saying if he waited and saw the results of the next quarter and it was high, performed well, what are the chances they would have announced good news? Okay. And what they're saying here is it's only 0.8. Why it performed well in the future? How come the good news we give here isn't 100%? Like, why isn't 100% we give good news? Well, is there exact tie between what we give in financial information and how it performs in our annual report? No. Okay? And we'll look at that in later chapters. Okay. Does this kind of make sense, this probability, what it means? Oops, I'm way down here. This probability. Okay, good. So then it's just math stuff, because I know you guys like math. 0.3 times 0.8 plus probability of low, which is 0.7, times the probability that we have low performing in the future. What's the probability we get good news? Well, without even looking at the numbers, we can see in the future and know it's going to be low. Is it a high probability or low probability? Between, we'll have an annual report that says good news. If we know in the future it performs well. Well, it better be low, right? Or something's really off with our, what's the word? Accounting. So 0.7 times, it is low, it's 0.1. And we get 0.77. So that is the probability high performance given good news has occurred. And again, it's not 100% because there's not a 100% matchup between the annual report in this case and the stock price. Okay? For example, 2007, 2008, although the banks and financial companies were the ones that started the crash because of what they were selling, you could have had a perfectly good construction company going and it was running well. Is your stock price going to go down? Yeah, because the whole market started crashing, right? Does that make sense? Okay. Okay, now, one other thing, a little thing that I want to throw in there before we leave this example. So, if that is the probability of high given good news, what do you think the probability of low given good news is? Well, remember, we match up the last two, the last letters, last occurrences, and they add up to 1. So, if we're matching GN, what's this going to be? Yeah, 1 minus 0.77, which is 0.23. Okay, last thing on this little question is, have we calculated out for Bill? No. He's waited, got some news, now he's got revised probabilities. So let's build them into his calculation for utility. Anyone still need this? So now we need calculation for utility of Bill's utility with the new info. Okay, so basically his utility for the stocks is going to be the probability of high given good news has happened times the utility, which we said was the square root of the payoff. That hasn't changed from our little table, plus the probability of low given good news times the utility. So the only thing that's changed in this formula from this last page, if I can just put it up for a sec. Notice we did high utility, low utility. Thing now is high utility, but good news has already happened, so we had to calculate the revised probability using Bayes' theorem. And then low given good news with utility. So the expected utility of A1 given good news is 0.77 times 40 plus 0.23 times 0. And that's 30.8, I think. I don't think it's 308. Can't quite read that. So this is the utility of investing given he's received good news. Now, has the expected utility for the bonds changed? No, we didn't do anything with them. So it's the same, it's 15, which was 1 times 15. And what units is utility in again? Okay, or happiness, whatever you want. So you can put a little happy face there if you want. So, which is Bill going to pick now? Stocks, excellent. Higher utility. Okay? So this is a numeric of how waiting for information will change the probabilities of what we're thinking, right? For example, now this is a numerical because jobs are much less numerical than stocks. So, your job, 2 interviews, you don't know which you're going to take. You think they're the same salary, right? All article and positions are roughly the same depending on the firm, and so on. And your decision right now, you've got kind of probabilities. Yeah, you know what, I'm leaning towards this one, not so much this one. Okay? Given what you know. Well, you have your job interview. Does that give you new information? Yeah, they might not tell you all the details, right? It's your first job interview, and a lot of places give more than one. They might not tell you a lot there, but what have you learned about the people? You've had a glance of what they're like, right? And their personalities and stuff like that. So you, coming out of both interviews, have revised your probability. Of course, built into that, if you did in each interview, which will change those probabilities and so on. But without thinking, when you think about it, if you're going for your, and you come home after both and you're sitting there thinking about the two companies, your feelings for them will have changed after that first interview. And those feelings are your probabilities that you're putting in there. Does that make sense? This is just numericalized. They didn't just make this up and go, oh yeah, this is how people work. They've done it over and over. It's usually a lot of undergraduate students they do it in, and usually in psychology and economics. And they find this kind of stuff out. Okay? So that is the numerical question for chapter 3. So there'll definitely be this question on your final, till the final. Okay, let's finish off the PowerPoints unless there's questions. You guys are such a quiet group. I guess it's hard when everybody's masked and stuff. So that was really to give you an understanding of how our thinking underlies our decisions and what happens for weighting. From an accounting perspective, why it's important is the more information we can give, the better they are, the decision makers, at predicting what can happen. Okay, so therefore, we want to predict futures returns, investors want to. Historical cost financial statements, they're weak. Okay? That's why if in management discussion and analysis or in a press release, you can put out visualizations, same data analytics that can highlight some of your performance, where people can understand it, because visualizations grab you much better than always reading financial statements. Okay? That's why you want to do things like that to supplement just our quarterly statements, because they're all. So predict future cash flows rather than future income. So that's another thing. Don't forget, we use the accrual method, right? So our focus in the past has been on income, but that might be getting a little stale. So with non-ideal condition though, that's hard to do. So cash flows and interest rates are uncertain and hard to predict. So if you're ever looking at a question and it's talking about uncertainty, or you're trying to make a decision, it's cash flows, interest rates, those that always two things that are unpredictable or uncertain. So historical cost isn't perfect. But current market rates, or valuing many of the present value techniques, also have problems. Market values are subjective, volatile, easily manipulated, may increase relevance, which is good, but what happens? We lose reliability. Throughout this whole course, as you guys saw in the conceptual framework in Accounting 315 right at the beginning, relevance, reliability. Really, you can't have both at the same time. Okay? So we give historian we bought 100 years ago, okay, not 100, is $60,000. That is absolutely accurate. We have the deed of sale. Does that mean anything to the investor for the future? Not so much. What else could we do then with that land? Under IFRS, we can value it at current value, right? Or market value. And if you choose that, you do it every so often. Now, Canada's relatively new to IFRS. They haven't valuing yet. No one's really bought onto the fair value, probably because our largest trading partner is the US, and they, of course, are using FASB, which doesn't allow for that. But you could give that information supplementary in the notes, right? Kind of like they do with reserve recognition accounting for oil and gas. So that's one way to build in extra information without what you perceive as the quality of the financial. Okay? So one alternative is use historical cost while providing present value information as a supplement. And you guys are right in the middle of it. In terms of changing financial statements, they're going to change in a huge way over the next 15 years. So it'll be very interesting. They did some studies, though, in Europe once they switched to IFRS. And they found the companies that were revaluing their assets were actually the weaker economies, whereas the stronger economies would keep historical value. Why? Because their financial statements probably said enough, just the fact that companies were coming from those countries. Whether there were tighter controls, less possibilities for bribery, that kind of stuff. It'll be interesting to see which way Canada goes. I imagine it'll stay a lot more like the US, but if the US ever did the fair value, I imagine we'll see more change. Okay, financial information needs to be informative, but there are constraints. Cost versus benefits. Could we put out financial statements every day? Yeah, we could if we wanted. Would they be audited? No, so then we run into a problem. Maybe we could put them monthly, something like that might be better. But the costs versus the benefits, it's still historical information. It's a lot to do it. What are the benefits? Maybe not much. Materiality, it depends. What would change if we change the way we're producing our statements?